Hi, my name is Dan Garcia. I'm a teaching professor at UC Berkeley. I'd like to talk to you about how we give assessments. So today, the way we give assessments is in a large, high-stakes environment. Lots of people, large room, usually do it a couple times a semester. So the way it is now, the model is a fixed time, a term or semester or quarter, and variable learning. Students either get an A, a B, or a C, but they also get Ds and Fs. So that's already broken, that students are completing the work, the connection we have with them, and not all getting A's. It's painful and inefficient for instructors in the following ways. Well, most of the time with big assessments, you got to coordinate a few exams for large courses. Last semester, I had an exam that took me across 10 classrooms, and thank goodness I had a powered unicycle to get me there. Disabled student accommodations are really hard to manage. Every student has a customized need of special time, and having to work that through is really difficult. It's hard to write exams every semester. Many of us just take it for granted that that's what we have to do, but it's hard to write these exams down there. It really is. I have no real sense of how the class is doing now. Sure, I have active learning in class, and sure, I get a big, nice histogram at the end of my exam, but I don't really know today, right now, how my class is doing and whether they're struggling on something. And curbing cheating is hard. With all this pressure, you've got a lot of cheating going on from students who are in the back, and he's looking around here, and other issues like that. So that's really hard to manage at scale. It's really painful and inefficient for students as well. The formative feedback they're getting from these exams, I mean, they certainly get it from homework and projects and quizzes and office hours, but the real formative feedback for kind of exams that are for material that's kind of exam ready, like, boy, the hardest material in class only happens once or twice a semester. These are, again, we mentioned how high stakes these are. All these students are completely pressured to do this. Because of that, you have high anxiety. This mental illness is rising in our campuses, and there's cheating as well, and that's really an issue. And if it's wrong, if this, that particular question was wrong, that's burned into their record. And students really don't know what they don't know, what they do and don't know. They don't have that feedback loop. They're very tight. That happens, very, very seldom during the semester. And all the grades that these students are getting favor prior preparation. Certainly in the intro series, if you've taken courses, if you've done any computing before, summer camps, code.org, that kind of thing, the grades of students who had that experience are usually quite higher than students who are coming to it, a diverse group of students coming to it for the first time. So let's take a look at what we could do to fix this. So let me introduce you to a team. This is Craig Zillis and team of University of Illinois Urbana-Champaign. They built a system called the Computer-Based Testing Facility, or CBTF. So with the CBTF that we're trying to adopt at UC Berkeley, this is the way it could be. So in this new model, I've got fixed learning. This is every student gets an A, and variable time. You could imagine stretching the semester beyond the actual term limit and maybe going into the break and maybe going to the next semester if the student hasn't yet shown mastery in all the work. So it's really about mastery learning that we're talking about. This is really pleasant for instructors. You can spend more time with students because your exams are written for you. I'll get to that in a second. So how this works is you've got these mini quizzes. Imagine like Khan Academy generating these questions. You can imagine here's a two-digit addition with no carry. Here's a two-digit with some carry. So some of these are harder than others. And you've got these students just working through these kind of pretty regularly as mini quizzes, and they can, if you have enough facilities, you can have these be done whenever, not just once a week. Craig does it once a week with his team, but you can imagine these being, if you have much more facilities, being done, twice a week, 3 times a week, once a day, many times a day. That'd be wonderful. DSP accommodations are trivial. Here's an example in the CBTF space where you have a quiet, isolated environment. There's earplugs if you'd like them, and students can have as much time as they want. So all those accommodations are really very easy. And the idea is you're writing these exam generators. I showed you before the slide that had all of the additions. You can imagine spending a lot of time thinking about your programming courses and how to write question stems that can then have some generators for that, which is very exciting. Here's a picture from Khan Academy, the TED Talk, that talks about being able to look at how their students are doing. So this is all of the students over time, and let's say your class only ends here, you're only on the 20th day. So I could see at this point, well, some students are doing real well. This particular student has made some improvement, started low, made some improvement, and there's a whole bunch of students here that are still working on the kind of more basic material. So here's my students who are sprinting ahead. Here's my students I need to be working with. So maybe I need to be pushing these students to do some exciting things and to make sure that they're not bored, and I need to be supporting these students down here at the lower end. So this is great to be able to see this regularly. And cheating is really hard. If you do it well, and every exam is different, it's really hard. Even if a student, went right in and left, and then tried to tell the student everything they knew, that next student, if the numbers are different, I'd have to teach you how to do, say, 2-digit addition. Just telling you, my particular addition problem doesn't help you if you don't know the process. So that's a great way to curb cheating, to have every exam be different, thanks to these exam generators. And it's actually fun for students. Your formative feedback is continuous. You're finding out how you're doing at all stages. And so there's no, oh gosh, how am I doing on the midterm? No, every day you're working on something. And it can actually kind of be like a game if you gamify it in some ways. Because the exams are low stakes, they should be fun. The students are hopefully doing very well. If it's wrong, you can override it tomorrow. There are different policies you can have with these exams that if you didn't do well the next day, and by the way, Khan Academy just by default does this. If you didn't do well today, that's no problem. You don't get penalized for not learning it today. This is Carol Dweck's, the growth mentality, the growth mindset. You just don't know it yet. So the idea is, well, you don't know today. There's no penalty for not knowing it today, and we can, you can work with the students and have different policies to support that. But you, in theory, could have a full clobber policy, which is if you learn it tomorrow, then you get credit for learning it today. Here's a concept map. Again, this is just a screenshot. There's a vision we have for this from Khan Academy some years ago, where you're showing the student exactly what they need to learn. This is a concept map of what they're learning in that class. The stars here that they showed were the things they'd completed. This shows you the connection where the students might even be able to drive their own learning. If this division's getting really fun, let's see if we can knock out a lot of division, because there's not a lot of dependencies here. So the students can actually jump ahead if they wanted to. So they don't have to follow your pace. They can follow ahead. And they also know at any stage, look, I've mastered this. What do I know? I've mastered this material. I'm still working on this. This is, again, Vygotsky's ZPD, the Zone of Proximal Development. These are things I'm working on. These are things I don't know yet. So it's very clear to students what they're working on. And finally, they can't finish the course until they've made a nice blue star on every single element here. And it might take more than a semester. It might take more than a term. It might take more than a year. We actually talk in Berkeley about some of our intro students. If they just gave them a year to do CS1, the students who came in with no prior programming experience, we believe would do much better. So we're thinking about what would it mean to take our CS1 and stretch it over the course of a year, if that's what it takes for our students who haven't seen this material before to do well. And every student walks out with an A. I'll say it again. Every student walks out with an A. And you might say, well, what happens if a student's a senior and they didn't finish? Well, I'd say, okay, you're a senior. We'll just figure out how many of these you've completed, what percentage you've completed, and factor that in with other homework and projects and things, and that's your grade. So that it falls back to no worse than we have now, but in the best model, every single student gets an A. Mastery learning, thanks to Craig Zillis and team's CBTF. My name is Dan Garcia, and I approve this message.